In this video, we are going to be talking about how to dissolve solutes faster. Let's first talk about solids dissolving in liquids. First of all, crushing. If you take your solute and you crush it, you end up increasing the surface area. And so this causes the solvent to be able to quickly surround each of the smaller particles and dissolve it. So the surface area is increased, therefore the solvent can get to the solute. Next, stirring. When you stir, you expose the solute to fresh solvent. So looking here at cup B, when the solute is dissolving, the solvent quickly forms a saturated solution around the solute. And recall that saturated solutions cannot dissolve any more solute. So this is going to dissolve very, very slowly because it's hard for the solvent to get in to reach the solute. So stirring will remove that saturated solution around the solute and bring in fresh solvent or fresh water. Next, temperature. As you increase the temperature, you increase the solubility. And this is only for solid solutes. So in previous units, we have looked at these solubility curves. So the line represents a saturated solution. Below the line, that would be an unsaturated solution, and above the line, as long as conditions are right, that could be a supersaturated solution where you heat it up and then you cool it down and it remains dissolved. Not all solutes can do this because it's so unstable. So it's easier to make a supersaturated solution with some solids versus others. Besides being above the line, it could be supersaturated, but it also could just be not dissolved, meaning that as you cool it down, it drops out of solution. So if I were looking at KNO3 and I was right here on this point, so about 75 degrees Celsius and just below 100 grams of solute, would this be saturated, unsaturated, or supersaturated? Well, it's below the line, so it would be unsaturated. If I were to cool it down, eventually I'd come to a point right on the line. Now it would be saturated. And if I were to cool it down more, I would find that it might stay dissolved, so that would be a supersaturated solution, or it's possible that right when I cross that line, it could drop out of solution. And then in that case, it would just remain saturated. And as I cooled it down further, more and more solid would appear on the bottom. All right, so you should be able to read a curve and figure out where you are. Again, on the line is saturated, below the line, unsaturated, above the line, supersaturated, or just not dissolved. All right, now let's talk about gas solutes. So gas solutes act a little bit differently than the solid solutes. So with gases, as you increase the temperature, less gas can dissolve. So my solubility decreases. So I learned this firsthand experience when I was teaching a class in college, and it was for elementary ed majors. And part of the unit, they had to learn how to take care of a pet. And so the pet that they had to take care of was a goldfish. So they came with their fish bowls, and we filled it up with tap water from the sink, and I gave each student their fish. About 5 minutes later, students came up to me, 2 of them, and said, "Our fish died." And I grabbed their fish bowl, and it was warm. And I said, "You put hot water in your fish bowl." I was just amazed that they would do this. And they said, "We didn't want our fish to be cold." So what they did to their fish was they suffocated it. Because, as you can see with this curve, this is oxygen gas. As you increase the temperature, less and less oxygen can be dissolved in the water. So there just wasn't enough oxygen for their fish to survive. So trout fishermen know this law firsthand. Trout are very, very oxygen dependent. They have to have a very high amount of oxygen in their water in order to survive. And so where do you find trout? In cold, bubbling streams. So in this area. Once it gets really, really warm, trout can't survive in those waters. So there are fish that are more oxygen deprived tolerant. So in some warm lakes, fish such as carp can live right at the surface. They can even come up to the surface and gulp air because there's just not enough air dissolved in the water for them. So again, with oxygen, as you increase the heat, less and less oxygen can dissolve. Also, pressure helps with dissolving gas solutes. As you increase the pressure, you increase the solubility. And looking at this first picture, this essentially is describing how they carbonate beverages. So, how they carbonate Diet Coke or root beer. So, they'll have a chamber and they'll flood it full of CO2, and then they will increase the pressure by decreasing the volume. This will cause more CO2 to be dissolved into the sugar solution or the syrup or whatever it is that they make the soda pop out of. And then right when it is dissolved quite a bit, they will can it. So that will keep it under pressure. So when you go to open up your can of soda pop, what you are doing is you are lowering the pressure. This lowers the solubility, and you have a whole bunch of gases rush out because they can no longer be dissolved in that liquid because the pressure has changed. So this is why when you drink a soda pop, it's bubbly, is because that gas is coming out of solution because there's a temperature change. And you also know, if we go back to the last rule with temperature and pressure kind of work together. If you open a warm can of soda pop, not only will the bubbles come out fast because there's a pressure change, but also because there's a temperature change. So two things working against keeping that carbon dioxide dissolved in solution.